Hi, this is Dr. Pat TV. We are looking at functions and domain and range about functions. Okay. And so if you just kind of refresh your mind, domain of a function is a set of values that both make sense and are of interest as inputs. That's usually the horizontal axes, except for one example when we're dealing with supply and demand curves. But that's the only example that I'm aware of. So domain, we're talking about the horizontal axes, the x values, the numbers that we plug into the formula. And because we have business applications, we also have the issue about what makes sense for us. What are the interests that we care about? Maybe we only care about for a certain period of time. And so we restrict our domain, basically restrict where we're looking for whatever application that we have. And then range, that's the values of the outputs. They depend on what we put in. So you might see the range as the listing of the dependent variables. Domain's the independent variable, whereas range the dependent variables. So we're looking at the vertical axes, we're looking at the y values. So now for an example, how about Stephanie Germano? Geramanto or Mato, whatever that last name is, better known as Lady Gaga. So what we could do is for our domain, here's an example of what makes sense for us. So you could have a domain for us here from 1986 to the present. So we can go from when she was born till now, or we could actually do an example of 2006 to now. So we're looking at, we have different options for domains. And so if you want to wait till she gets popular and then use that for our domain of the area of the time period we're interested, we could do that. And then range, well, range always depends on what we're looking at. Are we looking at the number of articles written about her throughout the year? Are we looking for the number of times she's been on front page? Looking at her income. So basically what we're looking at is like the number of articles could be, in the thousands. The number of times on front page of a magazine could be, in the tens and the single digits, or up to 25. And income be a range from hundreds of thousands of dollars to millions of dollars. So depending on what the situation is, our range could change. All right, so now let's take a real life example or another example of domain and range and look at it graphically. What do we mean by it? And so we have a very complicated or complex graph here. We have a situation in business, you see a lot of these things. In order to save space or to really connect some ideas, sometimes you see graphs, basically two graphs at one time. What you see on the bottom row here on the horizontal axis is the years, the quarter that we're portraying. So this is 2007 first quarter all the way to fourth quarter of 2010. And that would be our domain, each quarter between 2007 and 2010. And so what we have there on the left-hand vertical side, you have basically the homeowner improvements, and these are in billions of dollars, and it's also a moving total. So it's basically the previous 4 quarters added together. So that quarter and the previous 3. So 4 quarters added together. That's what the moving total is about. And so what we have here is the vertical axis here represents billions of dollars. And for this situation, even though the axis goes from 100 billion to 150 billion, that's not the domain. The domain is not the tick marks on your axes. The range. The range is not the vertical tick marks that we use to make the graph. The range is basically the lowest Y value here at $106.5 billion all the way up to the largest, which is 146.2. So if we're looking for range on on a graph, we're looking at the lowest Y value and the highest Y value in order to determine our range. So our range then for our domain is the quarters. Our range then would be 106.5 all the way to 146.2. Now on the second graph here, we go to the right side and our tick marks are listing negative 30% to 40%. So that's basically the rate of change or how things are changing from one quarter to another in terms of these 4 quarter moving totals. And so for our range on this, we go to the lowest one, which is here at negative 16.1, and then we go to the highest, 6.8. So the domain is going to be the same, but our range is going to be that listing of y values, negative 16.1 to 6.8. So that's how we do it graphically. Now, if we're looking at formulas, if we're looking at the symbols, basically we're looking at the list of numbers that we can put into the formula. We're looking at the listing of the results, the possible results. But now when we're doing formulas, basically I start off very optimistically, or for domains, I'm looking at what I can put in, and I start off thinking I can put in every number except for the restrictions, and we're playing with 3 restrictions. The first restriction is the number that makes 0 in the denominator. Can't put a number in there that makes 0. It's nothing I got against plugging in 0. It's a number that makes 0. And then also numbers that make negatives and square roots we can't have, so we've got to throw those out. And then for logarithms, we've got 0 or negative. We can't use x values that make 0 or negative in logarithms. If you're not familiar with logarithms, just to kind of take a look at some other YouTubes, or we can I'll be doing this later on in the term. Okay, so how do we do this? So here's some examples. I'm starting off with this one function here, 34x squared minus 7x plus 12 over 13. Now I'm noticing that there is a fraction here, so I got to be careful. But there are no x values in the denominator of this fraction, so that means we have no restriction. So basically, the domain of this function right here has no restrictions, so we use everybody, which basically means negative infinity to infinity. And that's how our interval notation would be. So I'm using everybody, and how do we write mathematically everybody? Basically, negative infinity, comma, infinity. Another example here, I do have a fraction on this function. It's x minus 3 in the denominator. Don't care about what's on top. I'm only looking at the denominator for my domain. And basically, I want to use everybody but the number 3. And so when I do this, I'm going from negative infinity to infinity, but I'm jumping over 3. Now, how do I know I'm jumping over 3 in this notation? I'm noticing the parentheses here. So the use of that parentheses right next to the 3 here means exclude, do not use. Use everybody up to it. So I'm using everybody between negative infinity to 3 and then 3 to infinity. I'm using everybody like that, but not 3 itself. That's what the parentheses is saying. And then for another example, how about the square root of 4 minus x? To start off with this one, I look at and see what makes 0 inside there, and that would be the number 4. And then I have to make a choice. Do I use the numbers to the left of 4, numbers smaller than 4, or do I use numbers to the right of 4, numbers that are bigger? And so just go ahead and take an example. Pick a number that's bigger than 4. Plug it into the formula, like negative 10. If I plug negative 10 in there, because of that minus sign, the subtraction, that's going to make my negative 10 into a plus 10. And so that would make positive inside. So it's good. If I plug in a number like positive 10, well, that's going to give me 4 minus 10, creating a negative 6, and that's bad. So I want to use everybody to the left of 4, numbers that are smaller than 4. And 4 is okay, because you can have the square root of 0. That's why you're seeing the square bracket right there represents include. So I'm using everybody to the left of 4, everybody that's smaller than 4, and because that's a square bracket, I'm telling people I can use 4 as well. And so that's the interval notation there. Use the square brackets to include, the parentheses to exclude. And whenever you're talking about an infinity, you always have to put a parentheses because you can never get there. You can never get to infinity. So that's why you can't include it. It's kind of like me having a party and sending out invitations to George Clooney and his new wife. It's just not going to happen. I can send it, yeah, but we'll never get there. It's never going to come. So then you exclude it. You use the parentheses. Okay, hopefully this makes sense. Talk to you later.